today with the SCADA system. Has anyone has an idea about an ICS SCADA system, Shabab? What is it? Anyone? Have you came across to this word before?
I never heard of it, doctor.
You remember what we said last time? What we are saying in CPS in general? We are saying that if you remember, just let me. Let me try just to open Jamboard.
Is it, doctor, for industrial work?
Yes, it is for industrial work, of course, yes. But basically, in any CPS, okay, in any CPS, what we have been saying, if you remember what we said that, remember the data model we specified, okay? Of course, here, for instance, you do have device, and you do have, let's say here, you do have, we do have device levels. Then what comes after the device level? Okay, let's say these are your sensors. Okay, the edge network. Okay, and this is the gateway. And what we have after the device level? The control level. Control level. Yes. Okay, the control level. Okay, we're not going to display the cloud level. Just want to make sure that now the idea about any CPS, you have sensors. Those sensors are controlling some specific physical, for instance, environment, like, for instance, pressure or collecting temperature, data about temperature. That data will be sent, okay, to the control level. There will be some analysis of that data. Then here we are saying the data is sent, or let's say collected, or aggregated data. Okay, it is sent, of course, using the gateway. Yeah, I'm not just showing like it's like from the whole environment through the gateway. It is sent to, let's say, to the control level. Then doing the analysis of the data. Now, when we do the analysis of the data, we need to send back what? We need to send back some control, because this is the idea. Okay, if you remember, Shabab, when we did have, for instance, you have a house. Okay, inside that house, you have let's say inside the house, I do have a smoke detector. Smoke detector, for instance, temperature sensors. Okay, and you do have an AC inside. I do have an AC here inside my home. I do have an AC that can be controlled. Okay, those sensor nodes, temperature sensor, will send data, will collect data. Okay, they have been programmed, for instance, every 5 minutes or half an hour, whatever. They will send their data, for instance, to your computer or to your mobile. Okay, let's make it just as simple, to your computer. This is the control one. You analyze the data. Okay, if you see, for instance, that the data of the temperature is higher, for instance, you will send a command. Okay, you will send some command to the AC. For instance, imma on or off. We don't care. Depends of, let's say, the data, the read data and analyze the data. Because in the whole thing is what? The whole thing is collecting data is not enough. I am going to collect data, then what? I will analyze the data. Then if I analyze the data and do nothing and take no action, so what is the purpose of having a smart home? The smart home is one thing to send the data to, for instance, to send some commands, okay, to get benefit of such a smart home. If I do have, for instance, a CCTV camera that is sending images to my computer, okay, to the control room. We call it, let's say, control room. You have a big room where you do have, when you see everything that is happening here. So what is the point of saying that through the video there is a thief inside your home and you don't send any action? If I see, for instance, a thief, I can, let's say, trigger some alarm, or to some light, to some buzzer, some sound, in order, for instance, to try to make the thief evade, for instance, okay, or escape. So this, the main thing is the command. This is the basically when we talk about an ICS. When you go to a big, okay, when you go to the big infrastructure, okay, like for instance, smart grid, okay, there should be some way of controlling the smart grid. There will be some place, okay, this is the place, for instance, where everything, okay, the control of SCADA, that's SCADA, sorry, control of that smart grid, okay, and we monitor, we look at what is happening in the smart grid. There will be some data that will be sent to the control. We do have here people working on this area. Let's say you do have a building with a big room with televisions and screens. They are looking exactly, monitoring everything in the smart grid. You do have many complex systems, okay, from the data, from graphs, from everything, that will be displayed in this part of, let's say, the network. This is what we mean by SCADA or ICS. This is the place where everything is controlled. You receive data and you send back control, you send back command, action, what you have to do. You remember when we gave an example of it is here, the water, you are controlling the water. I'm controlling the level of the water at the barrage, for instance. And the level of the water is sensed by a sensor. The sensor will send data to a control room, okay? And the control room, they are monitoring the level of the barrage. And when they see that the barrage has reached some specific threshold, they will send command. And this is the main thing. They will send command to a device, an actuator, for instance. There will be here another device beside with that sensor, that the command will be sent to close the valve, will have to open the valve based on what the data has been read and analyzed. So everything is in this room. We call that one the SCADA, ICS SCADA. Okay, Shabab, there will be some intelligent devices and there will be many things. This is what we are going to look at, the security of this main place, main location. This is ICS SCADA. Because if this one is threatened and it is attacked, that means you will send, just for, imagine that the command, the instructions, the commands will be attacked and someone will change the data. That means you are going to send wrong command and so on. There will be some devices inside it in order just to make sure that what we are getting is to secure that ICS SCADA system. Okay, guys? So as we mentioned, we said that the cyber physical systems collect information, okay, and you do have embedded microprocessor. It is a complex system, okay, and you need to some specific, you do have some activities on those devices that needs to be monitored, and thus monitoring of those, what is happening, for instance, as I mentioned, in smart grid. This can be controlled by what is known as a specialized computer system. This is what we call industrial ICS, industrial control systems, or interchangeable. You can call them as SCADA, or that's why you put ICS / SCADA. I mean, it is very crucial to keep security at high level of that control part that will control specifically those critical systems, because if something happens in the smart grid control, okay, that means it will affect the lives of people, it will affect the business, it will affect the economy of the country, and so on. So it is very important to make sure that the ICS SCADA system, those computers that are controlling the smart grid or any types of nuclear plant, the command that are sent, the data that is received is correct, and no one has played with that data. Okay, so this is these are some implementation for the CPS, and where, for instance, the ICS SCADA system are in place. Okay, for instance, water supply, oil production, transport, telecommunication, all those big infrastructure. So that means the operations of the CPS need to be safe. Okay, when you send a command to close or to open some devices, you need to secure that command, and those devices should be secured and protected from any types of attacks, threats from human or from surrounding environment or weather or whatever. Okay, so we need to keep the CIA objectives in those devices. Okay, and as we mentioned, if they are compromised, they will have a big impact on and a big impact in, as we mentioned, the life of peoples and the economy. Okay, so this is mainly the security attacks that can be towards the CPS. You have eavesdropping, DOS, wireless jamming, and all those that we have mentioned previously. That means you need to secure your ICS SCADA system against such threats. Now, in terms of the functionality of the ICS, okay, it is, as we mentioned, it will get the data from, here we talk about the various remote instruments which are devices, okay, that will collect data and remotely, okay, because they are not on the same place. You have your system, ICS SCADA system in one place, and the field instrument or the remote instrument or the remote devices are in another place, maybe miles away, kilometers away from the ICS SCADA, and there will be different devices. You can have, for instance, pumps, transmitters, valves, actuators, okay? And you need to control those devices remotely. From where? From computers that are, let's say, in the SCADA system. Okay, you will have some computers with specific software that will receive the data from remotely from those instruments remotely, analyze the data, and send back some commands to those devices based on the analysis. Okay, so in terms of the component of the ICS SCADA, we do have computers inside that control room. Let me have a look at. Yeah, this is a place where you do have people or control room. You have people behind their screen. They do have a powerful computers. They do have many screens. Okay, I think you have come across this picture or have seen something like this. In some documentary, in the news, okay, and you will find that people are looking at some data, and the data that is displayed on the screen is the data that is received from those devices, sensors that are in the field somewhere, okay? And you will see the graph of the data, the reading of the data. These people will analyze, will look at the data. If something needs to be taken as action, they will send commands through their computers remotely to those sensors that have sent this data. Okay, guys? So, as a component, what we can find in the ICS SCADA, you will find computers, you will find networks, of course, whether wireless or wired, some embedded device that will work together to monitor, manage, and control processes in those location, remote location, okay, area, for instance, oil area, or power management, or electricity, whatever, okay, and you send the command to those devices. So that means what we will have as a combination in an ICS SCADA as component, we have what is known as a field instrumentation, and the devices that are put in those area. We have what is known as programmable logical or logic controllers, PLC. Sometimes it is combined with another device which is known as RTU, remote terminal unit. Sometimes you do have one device that acts like a PLC and RTU. You have that communication network that will be used to send data. And you have ICS host software, the software that is running on that SCADA system to receive the data, to analyze the data, and to send back some command. In terms of, this is what you get something, an illustration of ICS infrastructure. You have field instrumentation, for instance, sensors or actuators that are connected to some PLC, RTU, through communication ways, wired, wireless, satellite, send data to the devices where you do have a database on that devices. Okay, they do have specific database and specific interface. You could here we talk about OPC server, which means you do have some specific interface that are that communicate with industrial hardware devices through, for instance, Windows or whatever the operating system. In terms of, as we mentioned, as an example of SCADA, a smart grid instrument that are controlled remotely through ICS SCADA control. Okay, and you have to control the power of the smart grid in order just to protect that critical infrastructure. Okay, and you need to, here we talk about, we need to minimize the downtime. Okay, specifically for the power grid or smart grid. Normally, we don't allow any power, any downtime of that plant because it is vital, because it is sending, or it is sourcing a town with a city with electricity, hospitals, and all the stuff. That means it is very important to keep that specific infrastructure as on 24/7, 365 days a year. So it is very important to secure it because there are many things depending on that smart grid. If this smart grid is threatened, if that smart grid is compromised via compromising an ICS SCADA system, that means many things will be affected. So it is very important to make sure that what you receive as data, what you take as a precaution to secure your ICS SCADA is very powerful. In terms of the architecture, what we do have, as I mentioned, we do have what is known as master terminal unit. This is the master terminal unit. It is the place where you can, for instance, to see, okay, and to, for instance, the place where you can be linked to the field in order, for instance, to send them some command. Okay, you start by, for instance, collecting the data from those RTU, those PLC that I have just mentioned. Okay, and you do, for instance, you do some specific action, some specific control that you will send to those devices that are in the field, in some area, for instance, at the border or whatever thing that you can sense and control and collect as part of the data. So for this MTU, or master terminal unit, it allows the user to perform those controlling functions on the, as I mentioned, the field devices. Okay, you control some switches, some valves to be open, to be closed, and so on. This is a schematic, another schematic way. Okay, where you do have, for instance, people here. This is a control center in Korea. They're controlling, for instance, level of waters. Okay, and they will look everything that is that has sensors in here will be displayed on their screen, and they will send the command, okay, to close, to lower the level of the pumps, for instance, or to increase their level, and so on. So everything that is happening here is controlled by these people. Okay. As we mentioned, another component of ICS SCADA is a PLC or a remote terminal. These are some specific computers. These are some computers. We call them a RAG computer. You see, yes, we do have a RAG computer. Why we are talking about a RAG specific industrial computer? Because those computers are not as normal computer that we are using, because they are used in the industrial environment. That means they should be strong. They do have cases different than the one we are having in our computers, because and they do have some specific instruction. They have been programmed to do some specific action and instructions, okay, some specific tasks, and they will always, okay, analyze the data that they are, because they will be connected to those sensors, and sensors will send their data to this PLC and RTU, okay. On themselves, they are connected to some actuators, which means that they are connected to some mechanical device, and they have the capability of triggering and activating those mechanical devices. Okay, so what you will have, for instance, okay, you will have, for instance, a node or sensors node. The sensor node is connected, for instance, to those, let's say, RTU and PLC. Okay, and that RTU will be, for instance, connected on itself on some actuator. Okay, actuator, which, let's say, open will close a valve or a switch or whatever, for instance, open or close. Okay, so this from sensor RTU to the actuator to trigger some mechanical. When I say that open close is something mechanical that will be triggered, because an RTU itself cannot do this. A sensor cannot act as an actuator. It is just collecting the data, reading the data. Okay, so we said that those PLC have an input-output. They receive and send. Okay, when you put input, that means you are receiving as an input, okay, and output sending the correct, let's say, action to be triggered on those actuators, okay, and they will continuously keep observing the state of those input devices. If they are connected to an AC, they will to the sensors, always they will check the data that is received by the sensors in order to take some types of decision. Okay, you will receive command from these people, okay, saying just send this command to the trigger actuators to close the valve. They will send that command. Okay, this is an example of a PLC, where you do have a lot of circuit, electrical circuit inside it. You have logical, okay, you have a logical command that you be sent and executed. This PLC will be programmed and to do some specific task based on the instructions received from the devices or from the command. As we mentioned, remote terminal unit or RTU, this will receive information, gather information from different sites, okay, and it is called, as we mentioned, it is connected to the sensors and actuators that will do some collect some type of information from different sensors, then sent, that data will be sent to the MTU. Okay, that means the collected data will be collected by this device from different field sensors, for instance, and the data will be sent to the MTU. And also, it will receive the command from the MTU to trigger some actuators. There are some images of some RTU. Okay, these are the RTU that you can see. This is cellular RTU, serial. This is the radio RTU. So there are different types of RTU in different fields. It depends of let's say the environment they have been put. Sometimes we said that the mini RTU, they do have some database, data in their database, okay, and they just wait for some request, for instance, to send or to transmit some data, okay. As I mentioned, sometimes PLC and RTU are combined in one device, okay, and sometimes they do have separate, they are considered as separate devices. This is another example. Okay, you do have, for instance, different sensors. Okay, and this is an RTU. This is an RTU that is collecting data from different sensors. Okay, and sending data through whatever way, whether wireless, GSM, mobile phone, to the monitor center, to the center where there will be some control and data analysis. The command will be sent back. Once received, it will send that command to the PLC or a relay or a water pump to switch on, off, or PLC to trigger some mechanical devices. But this is in general how, let's say, the link between the different types of PLC, RTU, command center, and the communication way. Next time, we're going to see the communication equipment. Once we understand the ICS SCADA component and devices, we look at some threats that might exploit those devices in order just to attack them. We stop here. If you have any questions, Shabab.